Student, we are studying our course, that is renewable energy sources, and in that we have started our third chapter or third module, that is the photovoltaic system, and in that we have covered different points. In our last video we have covered different types of the solar cell, which depends on the configuration or the formation of the junction in the semiconductor, insulator or metal, which is used in the solar cell. So depending on that, solar cell is classified into different 6 types, and in this video we study the different types of the solar cells which are based on the material to be used in the solar cell construction. So let's start with that. Types of the solar cells. Depending on the type of the material used for fabrication of a junction, they are classified as: first is the silicon solar cell, second one is the copper sulfide cells or cadmium sulfide solar cells, and the last one is, and third is the gallium arsenide solar cells. In our previous video we have seen about the types of the solar cell which depends on the configuration, that means the formation of junction between semiconductor material or metal semiconductor material or insulator semiconductor material. These are the different types of the junction formation, and depending on that, different types of the solar cell. But in this video we have to see different types of the solar cell which are based on the material to be used in the construction of the solar cell. So first is the silicon solar cell, that means the silicon material is used for the construction of the solar cell. Second one is the copper sulfide solar cell or cadmium sulfide solar cells. Cadmium sulfide is used for the construction of the solar cell, so the hence name for the solar cell is the copper sulfide solar cells and the cadmium sulfide solar cells. Next is the gallium arsenide, and which is the semiconductor material which is used for the construction of the solar cell. So this solar cell is known as the gallium arsenide solar cells. So let's see one by one. So first is the silicon solar cell. The silicon solar cell has been most developed and used cell to date. That means the silicon solar cell is a developed solar cell nowadays, and also we have seen in our previous videos the silicon solar cell have good efficiency and used cell to date. Silicon is the most common element on earth and is usually obtained from sand. We know that the silicon is obtained from the sand, and which is commonly used on the earth or also mostly found on the earth, so which is easily available on the earth, so we can use in large amount. At present, large crystals of silicon are grown and sliced into thin cells for further processing into p-n junction. That means nowadays large crystals of silicon are grown with the help of different techniques, and also these crystals of the silicon solar cell are sliced into thin cells, and this thin cells is used for the construction of the solar cell, that is the formation of the p-n junction. There are 3 types of silicon solar cell, such as single crystal silicon solar cell, polycrystalline or multicrystalline silicon solar cell, and third type is the amorphous silicon solar cell. These are the 3 different types of the silicon solar cell. First is the single crystal silicon solar cell. In that, the silicon is used as a single crystal, and next is the polycrystalline or multicrystalline solar cell. In that, the silicon is used as a polycrystalline or multicrystalline, that means there are more than 2 crystals. And last one is the amorphous silicon solar cell. We know that the generally solid is classified into 2 types, that is a crystalline solid and amorphous solid. So the silicon is also one of that. So the silicon is also have crystalline nature as well as the amorphous nature. So in crystalline nature there are again 2 types, single crystalline or polycrystalline. So these materials are used for the construction of the solar cell, and so depending on that there are 2 types of the solar cell, that is a single crystalline solar cell and polycrystalline solar cell, and third one is the amorphous silicon solar cell. Past cells that have been made of polycrystalline material have had relatively low efficiency. That means in a year before ago, the solar cell is made up from the polycrystalline material, and this solar cell have relatively low efficiencies. But nowadays the solar cell are constructed with the help of generally single crystalline solar cell, because if we consider the polycrystalline material and the single crystalline material, in a single crystalline material there is only one crystal, so there is no any obstacle or there is no any grain boundaries. If we consider the crystalline structure of the crystal, if there are more than two crystals, then these crystals are arranged in a periodic manner in a solid. We know that in a solid there is a periodic regular arrangement of the crystals, and these crystals has grain boundary. That is, suppose we consider first crystal, second crystal, third crystal, all these crystals are separated by the grain boundaries. These are known as, all the small regions are known as the grains, and the boundary between two grains is the grain boundary. And so this grain boundary is acts as a obstacle for the electron flow. So when we consider the single crystalline solar cell, there is no grain boundary, so the electron can flow easily, so there is a more electricity generation. And if we consider the polycrystalline material, there is a different grains of the same material, but there are number of grain boundaries, and these grain boundaries acts as an obstacle for the flow of electrons. So there is a less electricity, or there is a generation of the less current. So according to that, the single crystalline solar cell is the best as compared to the polycrystalline solar cell. So the grain boundaries inhibit electron flow and recombination results. However, if the grains can be made much larger than the thickness of the cell, it may approach the characteristics of the single crystal cell. That means if we increase the grain size, and which is the greater than the thickness of that cell, so we can approach to the single crystalline solar cell, and the single crystalline solar cell have good efficiency as compared to the polycrystalline solar cell. So the single crystalline silicon solar cell is generally used for the electricity generation. The amorphous silicon is made of thin film from the amorphous silicon. We know that the amorphous silicon and crystalline silicon, these are the two types of the silicon, and the amorphous silicon is used for the generation or the formation of the thin film, and this thin film material is used for the construction of the solar cell, and this solar cell is known as the amorphous silicon solar cell. These cells are made from layers having thickness less than 1 micrometer, and these cells which are made up of material, and the material have thickness less than 1 micrometer. Micrometer means 10 to the power minus 6 meter, so the thickness is less than 1 micrometer. Now the second type of the solar cell is the copper sulfide, that is Cu2S, or cadmium sulfide, that is a CdS solar cells. These can be a cheaper alternative to silicon solar cell. That means this is a cheap as compared to the silicon solar cell, but difficulties of encapsulation and prevention of deterioration are yet to be mastered. That means this has alternative to the silicon solar cell, but not good as compared to the silicon solar cell, because it has some difficulties. The highest efficiency observed in this film solar cell is nearly 9%. That is the efficiency of the cadmium sulfide or copper sulfide solar cell is nearly about 9%. A thin layer of metal such as a tin oxide is deposited on the glass substrate. That means the thin layer of the metal, that is tin oxide which is deposited on the glass substrate. Glass substrate means the glass on which the film is constructed, and this is known as the glass substrate, and on that there is a tin oxide layer or deposition of the tin oxide. This followed by the thicker layer of N-type cadmium sulfide and a thin layer of the P-type copper sulfide. That means the first material is the glass substrate on which the deposition of the tin oxide, and after that there is a N-type cadmium sulfide on which is the thick layer, and after that there is a P-type material, that is a P-type copper sulfide. So this is the arrangement of the copper sulfide or cadmium sulfide solar cells. This is the basic CDS solar cell. So first there is a glass substrate on which the layer of metal, that is the tin oxide, and after that there is a CDS, and CDS means cadmium sulfide, which is the N-type material, and after that Cu2S, that is a copper sulfide, which is the P-type material, and after that there is again the SnO2 layer, that is a tin oxide layer. That means the glass, that is the substrate side which is exposed to the sunlight, so that the glass transport maximum solar radiation, and after that this solar radiation hits on the SnO2 layer, and after that the working of the solar cell started. So this is the basic CDS solar cell. Next is the gallium arsenide, that is a GaAs solar cells. It is called as a homojunction solar cell. Homojunction means there is a same semiconductor material which is used on both sides of the junction, that is the homojunction solar cell. The thin film gallium arsenide solar cell provides efficiency of 15%, whereas bulk gallium arsenide solar cell provides efficiency of 25%. That means the bulk gallium arsenide material is better for the solar construction because it gives 25% efficiency as compared to the thin film gallium arsenide solar cell. That means the thin film means there is a construction of the thin film with the help of different techniques, but it gives the efficiency which is 15% and which is less as compared to the bulk gallium arsenide solar cell. So the best material which is used in the solar cell, that is a bulk gallium arsenide. The high efficiency of this solar cell is due to absorption of broad range of solar spectrum. That means this material absorb the nearly maximum radiation from the solar spectrum, so it gives the maximum electricity. So the efficiency is also high. They stand at high temperature without losing efficiency. That means they are able to bear the high temperature, and so that due to high temperature we get the maximum amount of heat or maximum amount of temperature, so that the maximum amount of intensity, and due to maximum amount of intensity we get the maximum current and electricity, so and without any losing efficiency. So this is the advantage of the gallium arsenide solar cell. Hence these solar cells are used in a concentrated. We know that in a concentrated the solar radiation is focused at a particular point, that means the intensity at that point is very high. So for that intensity is high, that means the temperature is also high, and this material is able to withstand the high temperature. So this gallium arsenide solar cell is used in a concentrated to generate electricity. So this is the basic gallium arsenide solar cell. The following figure shows the schematic of gallium arsenide solar cell. In gallium arsenide solar cell, the first layer is the N-type gallium arsenide. That means the N-type material of or N-type gallium arsenide. After that there is a P-type gallium arsenide. That means the N-type and P-type gallium arsenide both are the semiconductor material which are placed in contact. So there is a formation of junction. Now after that there is a P-type gallium aluminium arsenide. So this is the p-type material. So this is the basic of gallium arsenide solar cell. As is shown in the figure, p-type gallium arsenide is diffused on the n-type gallium arsenide. That means the p-type gallium arsenide which is diffused on the n-type gallium arsenide. The another layer of p-type gallium aluminum arsenide is diffused over a p-type gallium arsenide. That is the topmost layer, which is the p-type gallium aluminum arsenide, which is diffused on the top of the p-type gallium arsenide. The gallium arsenide solar cell can be manufactured as a single crystal or polycrystalline solar cell. That means these solar cells are constructed in both ways, that is for the using single crystal or using polycrystal material. So this is the advantage of the gallium arsenide solar cell. So these all are the different solar cell types which are based on the material used in the solar cell. There are different types for the solar cell, but we considered only these three types. So also there are different materials which are used in the construction of the solar cell, such as indium tin oxide, that is ITO, and other all different material, and these materials are constructed, these material are used to construction of the solar cell with the help of different techniques, generally thin film techniques, or sometimes we can deposit the film with the help of spray pyrolysis. So these all are the different techniques which are used for the synthesis of thin film, and these thin films are used for the this semiconductor. Generally these are the semiconductor material and which are used in the construction of the solar cell. So why we use only semiconductor material? Because semiconductor has a particular band gap so that it can absorb the energy from the photon. These but which photons? The photon which has energy nearly equal to the band gap of that semiconductor material, so that this energy it's absorbed by that electron which is in the valence band of that semiconductor material. After that there is excitation of the electron, that is there is a formation of the electron hole pairs, and after that there is a recombination, and after recombination we get the that is electricity, and so this electricity is used for the different, can be used for the different purposes. So this is all about the solar cell and its different types. So solar cell classified on the basis of the junction formation and also on the material to be used for the construction. So this is all about the solar cell types. So in our next video we will continue with different point. So we will continue with that.